guys, so today I'm going to be talking about dipole-dipole forces, and let's get started. So you might be wondering, what are dipole-dipole forces? So they're a non-covalent bond, and they don't share, which means that they don't share valence electrons. So let's get started with what dipole-dipole is and kind of break it down. The key to dipole-dipole is the electrostatic force, and when two polar molecules meet. So the two molecules have to be polar in order for them to become a dipole-dipole force. So I'm just gonna give you guys a little information about what polar molecules are so we can figure out what dipole-dipole is and what it looks like. So just in case you want to make sure that you are drawing a polar molecule, there's a couple rules. You need to make sure that they're non-symmetric molecules. So when you draw them, do they look symmetrical or are they more equal? And then also the central atom has to be surrounded by the non-identical electron groups. Whereas the nonpolar molecules, they'll look more symmetrical when you draw them, and the symmetric molecules have a central atom surrounded by identical electron groups. If we take a look at water, which is a pretty basic molecule, you can just look at your periodic table. And so we're going to grab two hydrogens, so H, the H, and then an O, and then you just look at the charges. H's are +1, and then your O is going to be a -2. So these are actually going to be the positive charge. Since they have the +1s, they have more force pulling them towards the positive. So next I'm just going to show you one more example. I'll do hydrogen sulfide, which is H2S, so S, H, H, and then we're going to look at the formal charges again. So these are +1, +1, and this is going to be a -2. And again, the negative charge is going to be with the sulfur. So we're going to do, and this symbol just means the electronegative forces between the two. So here's that. So now that we have a better understanding for the polar molecules, now we can draw the dipole-dipole forces. So for hydrogen sulfide, we can create a dipole-dipole force with this. So I'm just going to put them. So again, just gonna create the same molecule that we did, the same polar molecule that we did before, and then you're just going to connect another molecule again. So you can either connect, let's see, we can connect the sulfur, and that's how you can create the force. Just lastly, I want to give a couple examples of other different real-world dipole-dipole forces there could be. So we could do hydrochloric acid, which is HCl, water, which is H2O, which can turn into hydrogen bonding, but it is still a dipole-dipole force. Carbon monoxide. So that's what dipole-dipole force is.